So we're going to continue our work on proofs, specifically focusing on lines and angles. So using all of the properties that we studied in the last unit. In order to prove something, it seems fairly self-evident, but it's worth pointing out that you have to use statements that are true. If we all agree that something is true, then that argument is going to be more likely to result in a true conclusion. So in order to do this, we're going to talk a little bit about what truth means in math. And this is actually, even though it seems like we're relating a lot to English and kind of how things are spoken in English, these have a lot of implications for mathematics, especially math related to computers. So if you're interested in a job in the computer field in the future, I would pay close attention. So the first thing we're going to talk about are some vocabulary words. So if we're talking about conditional statements, and that's the majority of what we're going to talk about today, we're talking about an if-then statement. So if the hypothesis is true, then the conclusion theoretically is also true. So if 2 points lie on the same line, then they are collinear. So this is an example of a definition that's been written as a conditional statement. A conditional statement can be proven incorrect or false if you can provide any single counterexample. So one counterexample causes the whole statement to be considered false. So for instance, if x squared equals 16, then x equals 4. Even though this is seemingly true, 4 squared is 16, you have the counterexample that x could also equal -4. So if x squared equals 16, then x could be 4, but it could also be -4, which makes the statement only partially true. And since the applications for this are often in computers, think about how a computer thinks. It can't see the gray area. It's going to want black or white. So it's either true or it's false. There's no partially true. So if it's partially false, the whole thing is considered false. Now we have a few things we can do with a statement that change the meaning slightly, and they have specific names. So we're starting with an if-then statement. If the measure of angle A is equal to 30 degrees, then angle A is acute. Since 30 degrees is by definition an acute angle, that would be a true statement. However, if we change the order of things, it may or may not be a true statement. So the first is an inverse. We're going to change the hypothesis and the conclusion to their opposites. So the hypothesis here is the measure of angle A is 30 degrees. So instead of that, we're going to do the opposite of that. So if the measure of angle A is not 30 degrees, and the conclusion is also going to be negated. So angle A is acute becomes angle A is not acute. Well, let's think about this. If angle A is not 30 degrees, there are a whole lot of different things that it could be. And some of those would also be acute angles. So for instance, 29 degrees is not 30, but it is also an acute angle. So even though some of these would not be acute angles, it's still partially false, which means it's entirely or considered entirely false. Converse. So now we take the order of the statement and we change places. So the conclusion becomes the hypothesis. So if angle A is acute, then the measure of angle A is 30 degrees. Again, 30 degrees is an example of an acute angle, but if angle A is acute, it could be any number between 1 and 89 degrees. So that's not really a true statement. Contrapositive. So we're going to take that reversed order from the converse, and we're going to do the same thing that we did with the inverse, and we're going to make them both the opposite. So if angle A is not acute, then the measure of angle A is not 30 degrees. Now, if it's not acute, then it's by definition either a right angle, an obtuse angle, a straight angle. We don't know what it is. But if it's not acute, it cannot be any number less than 90. And so it, by definition, cannot be 30. So this is a true statement. We can combine these sorts of things into what's called a biconditional statement. These are statements that include the phrase if and only if. And we can break these up into a conditional statement and its converse. So it's interesting. Let's look at an example. 3 lines are coplanar if and only if they lie in the same plane. The conditional format of this is if 3 lines are coplanar, then they lie in the same plane. And the converse, remember that's when we change the order. If 3 lines lie in the same plane, then they are coplanar. This can be useful in the future, so just keep an eye out that that's called a biconditional statement. Now, some things that you're going to need for class, and you might want to review if any of these sound unfamiliar, are your definitions. We're going to need to know what congruent segments mean, midpoint, congruent angles, supplementary angles, complementary angles, and right angles. If you don't remember any of those words, please look up their definitions. We're also going to want to know our properties of equality. Some examples are reflexive, symmetric, transitive, substitution, addition, subtraction, multiplication, and division. Test yourself by trying to name what each of these mean. And if you don't remember one correctly, go back and study them, please. The last, for postulates and theorems, I'll provide a list that you can use during class to create your arguments. So you don't need to memorize these, but it may be useful to look over your notes from the last unit just so you're reminded what they look like. Thank you very much.